Here we're going to continue, looking at writing an equation from a graph. So we covered 1 and 2 in the last video. Let's take a look at number 3. So write an absolute value equation for the graph shown below. Now, I'm going to write this equation in the form f of x is equal to, I'm going to use vertex form, a, we're dealing with an absolute value here, so I'm going to say x minus h, the absolute value of that, plus k. Remember the last problems we had parabolas, so we were looking at x minus h squared. Here, we're looking at the absolute value of x minus h. Next, I'm going to look for some coordinate points. So here I have 2, -1. And then I can pick any point I want, but I'm going to go with this one here. All right, so that's 5, -2. All right, we're going to need a second point, so let's label that. So how did I get from the origin to that point, that vertex? It looks like I went right 2 units and then down 1. Right, so that right 2 is going to represent my h, and that down 1 is going to represent my k, and we'll get to the a value later. So how do I show this? Well, I'm going to do f of x is equal to a times the absolute value of x. Be very careful. I mentioned this in pretty much every video so far. If you're going right, it's the opposite of what you would think. So we're actually going to subtract 2 here. And then we went down 1. That's straightforward, so we're going to subtract 1. So we do have our k values plugged in and our h value. So now we need to figure out what a is. So you want to rewrite this equation using a y value instead of the f of x. And then I'm going to use the other point that I labeled, 5, -2, and I'm going to plug those in as my x and y values. This will help me solve for a, so I can see what type of stretch or compression I'm looking at. So y, just said we're substituting for that. So y is -2 is equal to a times x, which is 5, 5 minus 2, minus 1. So now that I have a as my only variable, I can solve for that. So we have -2 is equal to a times the absolute value of 3 minus 1. So -2 would be equal to 3a minus 1. Let's add 1 to each side. -2 plus 1 would be -1. 3a divided by 3, and a would be equal to -1/3. A couple things. That negative is good because my graph is reflected. And it's good that it's a 1/3. It does look like it's being compressed, not stretched. So I'm probably on the right track there. So to write my final answer, I'm going to say f of x is equal to, again, we want to write in vertex form. So a is going to be -1/3, absolute value of x minus 2, and then minus 1. It's always a good idea to check to make sure that your answers make sense relative to the graph that you were given. So this final answer, all right, this function here, the -1/3, the negative shows a reflection, that's good. 1/3 means it was compressed, which this graph does look compressed. And then the -2 and the -1 tells me right 2 down 1, which is what where my vertex is relative to the origin. So probably in good shape with that one. Number 4, they're telling us to use transformations to graph the function and state the domain and range. So this time we actually need to graph these. So this is going to be a bit more work, but it shouldn't be too bad. Looking at this graph, this 1/8, that tells me that there's going to be a compression. So a pretty flat graph here. And then this plus 10 tells me that the graph is going to shift up 10 places. All right, not that it doesn't look like, there is not an h value in there. So there's going to be no shift or horizontal shift left to right. So my vertex is going to be here at 0, 10. So remember your vertex is hk. In this problem, h is equal to 0 and k is equal to 10. So my vertex would be 0, 10. It's going to be the same. My axis symmetry is going to be there. Now I need other points. All right, I need to figure out what some other points are going to be on this graph. Do note that this graph goes up by twos, so it's a little bit different than some of the other ones we looked at. So each little box represents a value of 2. So how do we find some points here? I'm going to use my x and y values, and I'm always going to use my origin, my vertex as my middle value. So I'm going to use 0, 10 there, because I already have that one. Okay, it saves me some work. Now, from there, we've got some options. I'm going to try and pick numbers that are going to work out well with that 1/8. If I use my standard, and this wouldn't be wrong, if you use your standard -1, -2, 1, 2, you're going to wind up with some kind of you're going to wind up with fractions. And if I can avoid fractions when graphing, I definitely want to do so. So there's nothing wrong with using those numbers. As long as you graph them, you'll get the right answer. You'll get the same graph that I'll wind up with. But what I'm going to do instead here is I'm going to use numbers that look like they could be divisible by 8 because I don't want to wind up with a fraction. So I'm going to use -8, -16, +8, and +16. I like to keep the same distance between my points if possible, and the points above the 0 and below the 0, left and right, I want to try and keep them the same, just with opposite signs. So if I take this -16 and the rest of these numbers and plug them in as the x, what do we get as our y values? So the absolute value of -16 would be 16. 16 over 8 is 2, and then 2 plus 10 would give me 12. -8, absolute value would be 8. 8 over 8 is 1. 1 plus 10 would be 11. 8 plugged in, absolute value of 8 is 8. Again, 8 over 8 is 1. 1 plus 10 is 11. And then 16 over 8 was 2. 2 plus 10 would be 12. If you carefully choose these numbers, as I've mentioned before, these ones will match up. So I'm going to plot these now. So -16 will be 12, 14, 16. So 16, 12. That's going to be right here. -8, 11 is going to be here. Now remember that these go up by 2, so we need to plot in the middle of one of these grids. 0, 10 we've already plotted, and now we should start reflecting on the right. So we're going to look at 8, 11, which will be right there. Draw that a little better. There we go. And 16, 12. 12, 14. So it's going to be right there. Right. So I'm going to connect these dots now. They're not going to be perfect, but you get the idea. And what I do notice is that I do have a pretty strong compression. I do have a relatively flat looking graph, or it's getting to the point where it's looking flat. My graph was shifted up, and that's all we're looking to do, right? We're trying to use those transformations, in this case the compression, the shift up, to graph our function. Now they're asking us for the domain and range, right, so that won't be too much trouble. My domain, this graph goes forever left, forever right. There's really no limitations here. So my domain is all real numbers, and in interval notation, that would be -infinity to +infinity. Now my range here does look like it has some limitations. All right, it is going to keep going up, but it's not going to go below a specific point. And in this case, that lowest point is my vertex, which is 0, 10. So my minimum y value, the lowest y value, is going to be 10. 10 is included, so we want to put a bracket. And then we already mentioned this graph will keep going up. It's going to go up slowly, but it will keep going up. So this is going to keep going up until +infinity. And we always use parentheses with our infinity symbols. So go through the problem, kind of review, what worked out, how you did each step. But you always need to figure out what the transformations are first. I always like to list those and then work from your graph from there. One of the key things that you're going to want to get good at is picking these numbers here. All right. The better you get at choosing your numbers for your chart, the easier it is going to be to graph the whatever function you're given. If you pick the wrong, not necessarily the wrong numbers, but you may create more work for yourself. You may only wind up with the left side of the graph, which is going to be a problem because you don't know where the vertex might be if you don't find it to start. So go through those, use these problems. If you can do these problems, the rest of the problems in this type of section should be pretty easy for you. So that's it.